Hello everyone, I am Sabiha İrem. I am going to present you our research, an exploratory urban analysis via big data approach, Eindhoven case. In modern cities, the public spaces face the risk of degradation due to the lack of vibrancy, and measuring urban vitality becomes critical to make decisions in regenerating the public spaces. But urban vitality is an abstract, complex, and multidimensional concept challenging to measure, so we consider the popularity as a measure of urban vitality. And we ask a question, which is, to what extent the factors of urban vitality increase the probability of a neighborhood being popular? Our aim was to contribute to the degradation problem of the urban areas in two ways. First, defining the values associated with urban vitality, and then analyzing the values and their combinations which affect the probability of a neighborhood being popular. This is the conceptual model of the research. After extensive literature review, we found out these variables related to popularity, which are point of interest, accessibility, and perceptual qualities. The project's methodology follows three phases: data collection, data visualization, and data analysis. For each variables, we used different data types and sources. For popularity, geospatial data from Flickr API. For POIs, spatial aggregate data from BAG and CBS. For accessibility, travel data from Google Distance Metrics API. For perceptual qualities, statistical data from ODP. In data collection phase, we scraped the data from Flickr and Google and used open data platforms. For data visualization, we ran the spatial analysis in JS and mapped them into the neighborhoods. In the last stage, to check the probability of the relations, we conduct the Bayesian belief network analysis. When we zoom in each variables, for popularity, we scrape the number of geotagged photos within specified time based on the bounding box of the neighborhoods in Eindhoven. For POIs, we implement hill numbers method to calculate the density and diversity of the POIs. For accessibility, we use location-based accessibility index and calculate it for different transport modes. And we assume the origin points as city center and destination points as the center of each neighborhood. For perceptual qualities, we use related datasets to our variables based on the literature. For safety, we use perceived safety and crime rates. For population characteristics, we use racial composition and RAM population. And for social interaction, we take the social cohesion scale and activity level of the residents. These are the results of the spatial analysis. In the popularity map, the neighborhoods around the city center stayed in the fourth category as we expected. The POIs function, richness, and density follow a similar distribution, being generally the more dense areas also the ones with more functional diversity. For the accessibility by public transportation, driving, and walking value follow a similar distribution. In particular, the accessibility by driving and transit values have more similarities. For the perceptual qualities, the feeling of safety is seen as similarly distributed between the neighborhoods in contrast to the crime rates. The native population map shows us that the percentage of native people is higher than 58% in most of the neighborhoods. And when we look at the RAM population, in most of the neighborhoods, the population does not change significantly, which is a good for the resident satisfaction level. And lastly, the neighborhoods with very high participation in activities also include neighborhoods with very high social cohesion scores. The BBN network was structured to reveal the relations between the variables. Besides the relations, it is also possible to see the relative strength of the associations using Euclidean method by the average. POIs density had a close relationship with the accessibility variables, but none of the POIs variables were directly associated with the popularity. Regarding the accessibility variables, the probability of being highly popular decreases the probability of not being accessible by walking and driving. And it shows that popular places are more easily accessible by foot or driving. And regarding the perceptual quality variables, an only change in population had a close relationship with the popularity. According to the literature, we were expecting more relationships between the perceptual qualities and popularity. After evaluating the overall network, we played with the values and checked the results. First, the direct effect of walk accessibility on POIs density resulted in 86% of the chances of a neighborhood having very low walkability when a very low density is considered. And second, a high POI density generating a drop of probability being less popular from 83% of very low popularity to 66%. Third, the probability of high walk accessibility increases the probability of very high popularity from 4 to 22%. And lastly, the network between the feeling of safety, crime rates, activity percentage, and social cohesion score makes sense in terms of interconnectivity. Lastly, I would like to mention the limitations. The popularity variables was limited with Flickr data, which might be a problem because of the user's age group and private user accounts. It should have been supported by more georeference data from other UCG platforms. The accessibility index was limited with travel time and population, and other travel parameters might be considered as well, such as travel cost, impedance, distance. To conclude, we have complex network rather than our initial conceptual model. The project's results partially agreed with the literature research with a high level of accessibility by walk and POIs density associated with a high probability of popularity. In this sense, the results presented here support the contemporary urbanism trend, which is compact cities. Additionally, neighborhoods where the social composition is renovated every year, like in Eindhoven, are more popular than areas with a stable population. This result points to social dynamics as a relevant feature of popular and livable areas. This approach might contribute to the field of urban informatics and also has the potential to be used in real estate to evaluate the land price and in tourism to identify the hotspot places. The relations found in this research can be useful for policymakers in decision-making about urban development, considering livability to prevent degradation in urban areas. And these are our references. Thank you for your attention.